Thank you, Linda, and good afternoon, everyone. As Linda mentioned, this presentation is a series of 3 of them together, and we're really talking about the research we did in the last 18 months or so. So they are new results, as far as I'm aware, and this is probably the first research that has been done internationally. Just like to introduce the team first. So it is very much of a collaboration between AgriResearch, Otago, Callaghan, and Ferrier. So I'm going to talk about the sensory work. So AgriResearch team involves myself, Linda, and Marita, and also Fei Tan, Maritza. So Fei is my PhD student, and then she will follow up, discuss about her work on the volatile branch chain fatty acids. And then that will be followed up the last presentation by Mikhail from Callaghan, talking about overall fatty acids profiles in the sheep milk. Tracy and In from Ferrier also did some work on the oligosaccharides and salicylic acid, and we will not talking about that part of the work today. So the sensory work is actually done at Otago by a Chinese master student, Shirley, and also her supervisor, Aladdin. As Linda already mentioned, this is within the one large MB program, which was conceptualized in 2013. So we are actually in the 4th year and 5th year of the program now. The program itself has 4 components. So the work, the first presentation, 3 presentations we're going to talk about it, is part of the milk composition and processing. And I know there is going to be a presentation on the health benefits, and also there are others on farm, increase the milk production and environment footprint. What I'd like to mention is our industry partners. As Linda said, they are extremely critical for the program. So Kingsmead, Spring Sheep Dairy, and Marie Milk. Without them, a lot of our research won't be there, and certainly they helped us with regarding a lot of products and also the milk collections. Okay, with the work we're going to tell you about, essentially almost 2 years ago, let's say, we were asked several questions by our industry partners. The very first one is about sensory. You heard this morning a little bit from Andrea as well. So what we wanted to know is really what sensory attributes are perceived differently between cow, sheep, and goat milk from scientific perspective. And the second is we wanted to understand what are the differences in the chemical composition and the physical characteristics of the milk that may contribute to those sensory attributes. What we also wanted to understand is, once we have those knowledge, got those understanding, how the processing actually affects the sensory attributes, as well as the nutritional and the compositional targets that we're looking at it for sheep milk-based products. And the very last one I had left the question there is what we want to understand is what are the effects of feed qualities on milk composition and nutrition. Currently, we are actually analyzing those results, so I'm not going to talk about that part of the work at all. And I'm sure in 12 months' time, we will show you those results. So for the sensory work, we essentially collected 3 sets of milk powders. And the reason of the 3 sets is they represent roughly 3 different seasons: spring, summer, and autumn. So our sheep milk is from our stakeholders, Marie Milk and Spring Sheep Dairy. And we were very fortunate that Synlait donated us the cow milk-based whole milk powder, as well as the goat milk powder was from Nutrition Goat companies. Now, for the second part of the work, which is to do trying to understanding the processing, i.e. the processing from beginning of the raw milk we collected to the pasteurization heat treatment and to the spray drying of the powders, how those different stages of the processing actually influences some of the composition, and particularly those sensory-related compounds. So as you can see, there's a lot of sample work collected with the support and the help of our stakeholders. And we collected samples during the whole season in fortnightly interval. So there was 12 timelines collected the sample there. Now, I'm not going to talk about this set of a sample. The reason I'm showing there is later on in Faye's and Mihail's presentation, you will see them talking about the influence of processing. So this is essentially the sample we collected. So back to the sensory work again. So as I said, this work was done in Otago. So what we did was we specifically targeting certain populations as well. The reason being is our products are exported. So what we had is we recruited 12 Chinese panelists, and they are Chinese citizens, Mandarin speaking, and they have lived in New Zealand in less than 5 years. Okay, and an intensity scale I'll talk about later on as well. That's just a score. Okay, intensity scale for the attributes, sensory attributes of 0 to 150, just an arbitrary range and a number, were used to quantify the attributes. And the whole process was run in Mandarin Chinese. All attributes were generated in Chinese and then translated by the researchers. Okay. The sample were prepared by reconstituting the powders, the whole milk powders, so 25 grams in 150 ml of warm water for consumption purposes. So all of them were treated exactly the same way. To start with, just want to show you the compositional data. As I said, we reconstituted the milk powder in exactly the same way. Okay, but we do see from the results itself there are some differences there. To start with, the total solids reasonably at the same level of around about 15%. There's a little bit differences. That's due to the moisture in the powder. Couple of features I do want you to see. One is cow's milk got slightly higher lactose concentration just because of the differences in the ratios of lactose, fats, and proteins after drying there. And goat milk has the lowest fat content, protein and fat content. It is fat, lowest the fat content, and reasonably similar protein content compared with the cow milk. And sheep milk has the lowest lactose and reasonably high both protein and fat content. Now, these are important, so that's very much of a reason I wanted stated here, that cow's milk has the highest lactose after reconstitution, even though all of them got lactose. Goat milk has the lowest fat content, and sheep milk has the relatively high both protein and fat content. Okay, as I mentioned there, the whole sessions are run in Chinese. So here we generated 12 attributes from appearance to a bit of odor, so you don't taste those two. Then the participants drink the milk, so they will rate the tastes, varies from dairy taste to sweetness, bitterness, saltiness, and the very last one is about cowrie and sheepy and goaty flavor, that distinctive flavor just related to the milk. Then they also rated mouthfeel when they have the milk in the mouth itself in terms of creaminess and astringency. Then they will swallow the milk and rated again how they feel in the mouth after the taste. So we're talking about sweetness after taste, saltiness after taste, and dairy after taste. So 12 attributes altogether. It's a very pretty graph. That's essentially just giving you a quick overview of all 12 attributes. It's an average of 3 cows, 3 goats, and 3 sheep. So this is an average. I will show you other data later on a little bit more as well. The reason being it's just make the graph a little bit simpler. So the cow milk is the blue color, and sheep milk is the red one, and the goat milk is the green one. So overall, just think about it, is just initially you saw that picture. Both cow milk and sheep milk looks very different. Sorry, both sheep milk and the goat milk looks very different to the cow milk. And there is also some differences between sheep milk and goat milk as well. So essentially, all 3 of them do look different when, in terms of a sensory perception wise. Okay. When we drill down into a little bit more detail, and attributes along the top here, even though there looks like some differences there, statistically they're actually very, very similar. So in terms of a viscosity, creaminess, and just the basic dairy taste, dairy odor-wise, the 3 milk actually very, very similar. The major differences is down the bottom. All of those related directly to the taste, to the sweetness, to the saltiness, and to the cow, goaty flavor, that animal sort of a milk taste flavor, and as well as before, as well as while, during the consumption, and as well as after the consumption. So that's the statistical analysis of all the samples. So we treat all the samples individually. In this case, we'll not average them together again. So what we wanted to see is really those differences, whether it is attributed to the differences between the different species or the differences between the samples, even though we collected the 3 sets of the samples, spring, or summer, and autumn. As you see, there are some differences between the seasons, as I show you in the graph there. I'll show you later on as well. But from our statistic analysis point of view, there's really no statistic differences between the seasons. So we actually collected the samples well, and we got pretty robust results. The differences between the animals, as I mentioned earlier on, mainly the sweetness, significantly different between the 3, saltiness, and cow, sheep, goaty flavor. Then it's the 2 aftertaste. The aftertaste of the sweetness, aftertaste of saltiness. So they're very much related to those direct flavor taste. Just wanted to show you a little bit more sort of a detail of the data. And as I mentioned it, one is the sweetness, one is the saltiness. Now, cow milk is perceived most sweet. So, which is probably not surprising, because as I mentioned earlier on, cow milk actually had the highest lactose content. And goat milk and the sheep milk did not really show much of a differences between the 2, but they are different compared with cow milk in the sweetness. In terms of a saltiness, goat milk is perceived the most salty. And sheep milk is, although there are some differences, but not huge, is similar and perceived a lot less salty compared with the goat milk. Now, those 2 attributes, after they swallow the milk, are actually lingering around in their mouths. So the panelists rated them more or less in the same order after the milk has been consumed. So the cow has the strongest sweetness, and goat milk has the strongest saltiness aftertaste. Now, this is the most interesting flavor ranking, I would say, because they don't actually directly relate to anything. I'll show you in a minute as well. So it's about cowrie, sheepy, and goaty flavor. I was actually really surprised and interested as well. Those panelists actually can rate it just this sheepy and goaty and cow flavor. As you see here, there is a very little, very low, this kind of a flavor in the cow's milk, the blue one, and it tends to have a much higher intensity in goat milk. Sheep milk is more or less in between. Now, the error bar is quite big, and we're talking about 12 people here. And even with that data, we still be able to generate statistic differences between goat milk, sheep milk, and cow milk. So as I mentioned early on, we do want you to understand what actually contributed to those flavor tastes so that we can control it or manipulate it, whichever the way we want to work towards it. And what is really interesting to see here, I only show those which has the correlation. So say, for example, protein content does not have any correlation with any of those flavor intensity. That's why I'm not showing that data here. So to start with lactose, I mentioned earlier on, cow lactose has the highest, a cow has the highest lactose content, which also has the highest sweetness. So it correlates very, very well, sweetness with the lactose content. And similarly, sweetness aftertaste as well. What is really interesting is about the correlation, some of those tastings with fat content. So what we see is, for example, the bitterness, saltiness, and a salty aftertaste is actually very well inversely correlate to the fat content. And that's why I mentioned early on. The goat milk has the lowest fat content, and goat milk was perceived saltiest. Even aftertaste, still perceived saltiest. So the fat in the milk often can mask some of the flavors or some of the taste there, and that's a very clear sort of distinguishing differences between the goat milk and the sheep milk for that part of the reason. We also see other correlation, for example, fat with viscosity. We know that, even though we did not see much of the differences statistically in the perception of viscosity. What we also see some of other correlation between some of the minerals. Again, it is very well reported. Sodium, both sodium and potassium could influence saltiness perception. So just a quick summary. So consumers can differentiate milk from different species, and the biggest differences are in the taste-related attributes. So cow milk perceived sweeter and less saltier than both sheep and goat milk. That is largely related to the amount of the lactose in those milk, and probably also lack of other flavor perceptions there as well. Sheep milk perceived less salty than goat milk. That may to do with the level of the fat, and sheep milk certainly has the highest fat content, often helps mask some of the flavor attributes. Cow milk has the lowest cow, sheepy, and goaty flavor, and goat milk has the highest score. So sheep milk is somewhere in between. So from that, I'll leave it to my PhD student to tell you why those goaty and sheepy and the cowy flavors different between the three milk.